nylon. So already we have taken few man-made fibers. One is from the category of regenerated cellulosic fiber, that is viscose. Another we have taken acetate rayon, which is a modified cellulosic regenerated man-made fiber. Viscose is produced by using wet spinning method. Acetate rayon we have taken, which is produced by using dry spinning method. Today we are taking a fiber which is from the category of man-made synthetic fibers, and this is produced by melt spinning method. So we have taken one example of wet spinning, one example of dry spinning. Today we are taking a fiber which is example for melt spinning method. There are three spinning methods we have concluded in the previous classes: melt spinning, dry spinning, and wet spinning. So this fiber, we can understand melt spinning method by understanding the manufacturing of nylon. So discovery of nylon, it was discovered by W.H. Carothers, name of the scientist which discovered this fiber. The term nylon was derived from no run. No run means doesn't exhaust. Means it is indicating its durability. The name originally considered by its inventors to emphasize the durability of ladies' hosiery manufactured from it. In the beginning, it was used to produce ladies' hosiery, and the durability of that fabric was very high. And due to this durability, the term came as a nylon from no run. It can be defined or can be classified as nylon is a man-made synthetic polymer, polyamide filament or staple fiber, made wholly from raw materials from the minerals, that is coal, air, and water. It contains atoms of carbon, hydrogen, oxygen, and nitrogen. So this comes from the category of synthetic polymer, means the polymer is manufactured in the industry and that polymer is converted into filament or fiber, and the basic material is polyamide. The chemical structure is, the chemical found in that is polyamide. So it is put in the category of polyamide synthetic fibers. Different nylons are used or are manufactured in the industry, and the names are depending on the number of carbon atoms present in the molecule of raw material. जो raw material हम particular nylon के use कर रहे हैं, उस raw material में कितने carbon atoms हैं, उस number पर depend करेगा nylon का नाम. Different type of nylons we are using, और उन nylons को जो हम नाम दे रहे हैं, different name जो दे रहे हैं, वो किस पर depend करेगा? The carbon atoms present in the molecule of raw material. जो हम raw material use कर रहे हैं, उसमें जो carbon atoms हैं, उनका क्या number है, that will decide the name of nylon. So we can take some popular examples of nylon. You can understand this meaning of the last paragraph by this example. Hexamethylene diamine, जिसका फॉर्मूला यहाँ पे दिखाया हुआ है, CH26 NH2 NH2. So here you can see there are 6 carbon atoms. So hexamethylene diamine containing 6 carbon atoms, and adipic acid. This is the formula for adipic acid, CH24 COOH COOH. So here you can also see 4 + 1 + 1, 6 carbon atoms. So adipic acid also contains 6 carbon atoms. So the nylon, which is formed from hexamethylene diamine and adipic acid as raw material, because hexamethylene diamine, HMD, is having 6 carbon atoms and adipic acid containing 6 carbon atoms. And these are the two chemicals which are used as raw materials. So in the first one also 6 carbon atoms, in the second one also 6 carbon atoms. So the nylon which is manufactured from these two raw materials is known as nylon 6,6 and written as nylon 6,6. So this nylon is known as nylon 6,6 because both the raw materials are containing 6 carbon atoms. Hexamethylene diamine containing 6 carbon atoms, you can see in the formula, and this adipic acid also containing 6 carbon atoms. So the final material, the final nylon we are getting, that will be termed as nylon 6,6. Similarly, other nylons are named in the similar manner. So these two raw materials go through condensation reaction. So water is liberated and it is forming this, which is a monomer for nylon 6,6. And then condensation polymerization is taking place, means this reaction is a continuous reaction, and condensation polymerization is taking place, and we are getting this one, which is known as nylon 6,6 or polyamide 6,6. We take another example. The raw material, if the raw material is aminocaproic acid, here you can see the formula, aminocaproic acid, CH2,5 at one end, NH2 group, and at another end, COOH group. So you can see here C5 and C1. So C5 plus 1, C6 is there. So when this aminocaproic acid going through condensation polymerization, it is forming a nylon, which is known as nylon 6 or polyamide 6. Because only one raw material is there, aminocaproic acid. And this is containing 6 carbon atoms. So this nylon is named as nylon 6. Similarly, nylon 7 and nylon 11 are obtained from amino acids containing 7 and 11 carbon atoms per molecule respectively. Means nylon 7, so the raw material is containing 7 carbon atoms. Nylon 11 means the raw material is containing 11 carbon atoms. So it is known as nylon 7 and nylon 11. Another example, nylon 6,10 means nylon 6,10 is made by one raw material is same as nylon 6,6, hexamethylene diamine, which is containing 6 carbon atoms. And another raw material here is sebacic acid, which is containing 10 carbon atoms. And that's why this nylon is known as nylon 6,10. But the most popular nylon fibers which are used for textile purposes are nylon 6 and nylon 6,6. So we will take these two fibers, manufacturing of these two fibers in detail. So first we are taking manufacturing of nylon 6,6. And as I have already mentioned, the name of the raw materials for nylon 6,6 is adipic acid and hexamethylene diamine. These are the two raw materials used for nylon 6,6. So first we will take one method of producing adipic acid and one method for producing hexamethylene diamine. There are a number of methods used in industry, but here in this semester, in this subject, we will take only one method of manufacturing adipic acid and hexamethylene diamine. So here you can see, and the purpose is to show how we are getting the monomers, and the monomers are converted into polymers, and polymers are converted into filament or fibers. A brief introduction we are taking here. Details we will study in the coming semesters in fiber science and different subjects related with fiber science. An early method starting from phenol. We are starting from phenol, which is extracted from coal tar. So we can say the monomer is extracted from coal tar, which is a natural product. So from nature, we are extracting the monomer, and then this is hydrogenated. By hydrogenating it, we are converting this phenol into cyclohexanol. And then finally oxidizing with nitric acid, HNO3, in presence of metal catalyst at 60 to 70 degrees centigrade, this cyclohexanol converts, or it gives adipic acid, which is having 6 carbon atoms and shown in a ring form here. Then how hexamethylene diamine is produced. One example we are taking here, one method we are taking here. And in this method, we are producing or manufacturing hexamethylene diamine from adipic acid, which is also one of the raw material of nylon 6,6. So adipic acid को हम hexamethylene diamine में convert कर रहे हैं. So how it is converted, that is shown here by some chemical formulas also and explained here. It is subjected, adipic acid is subjected to a reaction. This is subjected to a reaction called amination. This is subjected to a reaction which is called amination. Amination means reacting with ammonia, a vapor of ammonia, in presence of boron phosphate catalyst at 350 to 400 degree centigrade temperature, means very high temperature. So when this adipic acid is going through amination process, it gets converted into another chemical known as diammonium adipate, which is an intermediate product. So here we are getting diammonium adipate. Then further dehydration is taking place, and on further dehydration, it is converted to adipamide. Adipamide on further dehydration gets converted to adiponitrile. And this adiponitrile can be reduced with hydrogen under pressure of 600 to 625 atmospheric pressure at 125 degrees centigrade in presence of nickel or cobalt catalyst in hexamethylene diamine, which is shown here. So in this topic, particularly the chemical names and all these terms and conditions, catalyst, temperature, pressure, you have to just cram, you have to remember it. And that's why we have taken only one method, so that it will be easy to remember in the examination. Now here the production of nylon 6,6 polymer salt from air, coal and water is shown in chart form, which we have already taken in reaction form is shown in a chart form, how we are getting adipic acid and then we are manufacturing hexamethylene diamine from adipic acid. So here we are starting with air, water, coal. So from air we have indicated nitrogen and oxygen, and water when reacting with coke, hydrogen is produced. So basically we are getting nitrogen, hydrogen and oxygen from air, and then this from coal we are getting carbon. So coal converted to tar, then phenol, then cyclohexanol by hydrogenating, and then converted into adipic acid, which we have already shown in reactions. And then adipic acid is converted upon further hydrogenation, it is and amination process, it is converted to hexamethylene diamine. So this flow chart is just indicating how these two raw materials are manufactured, which we have already taken in detail into previous slides. So it will be easy to remember it. And then this adipic acid and hexamethylene diamine react with each other. After mixing the solutions of both in methanol, nylon salt is precipitated. And this nylon salt is online. Nylon salt. Please keep muted to yourself. अपने आप को म्यूटेड रखें बेटा, बीच में डिस्टरबेंस होता है, आप किसी को कुछ बोल रहे हैं तो. Nylon salt is precipitated, which is separated and purified at this stage. So this is a chart which is indicating the manufacturing process of nylon 6,6 polymer salt. Now this salt is converted into filament. So production of nylon 6,6 polymer salt is again explained here. The purified nylon salt is heated. Then the salt which we are getting, that is heated in an autoclave, which is also explained with the help of diagram. Here you can see one autoclave is there. So this diagram will help you to understand these reactions and this process. The purified nylon salt, which we are getting from this raw materials, adipic acid and hexamethylene diamine. This purified nylon salt is heated in an autoclave under high pressure and high temperatures. It loses water and form hexamethylene adipamide. That is indicated here. This nylon salt, when heated in an autoclave under high pressure, it is forming hexamethylene adipamide, which is shown by reaction here, which polymerizes with further elimination of water. So water is liberating. That's why we can say it is condensation polymerization. and it gives nylon 6,6 polymer. This is chemical formula for nylon 6,6 polymer. This dot, dot, dot is indicating number of polymers, number of monomers joined together to form nylon 6,6 polymer. When required DP is obtained, which requires around 4 hours at 280 degrees centigrade in an inert atmosphere, polymerization is stopped. And then the molten polymer is casted into ribbons by forcing through a slit orifice, solidified by spraying cold water on it as it passes over a rotating drum. The product is then transferred to a disintegrator where it is cut into chips. And that can be understood with the help of this diagram also. Here an autoclave is there. So nylon salt is fed into this autoclave, and this autoclave is having one orifice which is in the shape of slit. So a slit orifice is there which is having a particular width, and from this we are forcing this nylon salt. So it is coming out in the ribbon form, and it is passing through this drum, rotating drum, and at this time we are spraying cold water jets on it. So this material, which is at a very high temperature around 280 degrees centigrade, coming from a slit of autoclave, is solidified by spraying cold water here. And then some air jets are sprayed when it is passing through these guide rollers. And finally, from these feed rollers, it is fed into disintegrator. And this disintegrator is having a specific function. This ribbon-like structure is fed into disintegrator, which is cutting them into small pieces, which is known as chips. And these nylon chips are collected into this container and then can be used for further process. So that is explained here. And these chips obtained from different lots are mixed to ensure uniformity of the final product and transfer to the spinning solution. To avoid the batch to batch differentiations between the nylon filament, what we are doing from different lots, all the chips from different lots are collected into a big container and they are mixed uniformly. So the final product will not have differences, load to load differences will not be there. Then these chips, which we are getting after this process, are used for melt spinning. So up to this, what we have done, we have produced polymer from the raw materials, that is adipic acid and hexamethylene diamine. And then this polymer is melted and converted into ribbon form. And then this ribbon form is converted into chips form. And these chips are used for the spinning process to convert them into filament or then cut into the fibers. So this diagram is indicating the spinning method used for nylon 6,6. And already I have mentioned melt spinning method we are using. So this is known as melt spinning method. And along with the melt spinning, this diagram is indicating the melt spinning. And this another diagram, in one slide I have taken two diagrams. This is one diagram, and just to show the continuity of it, the same bobbin is indicated here, and it is drawing process, D-R-A-W-I-N-G. Drawing means we are stretching to make the molecules oriented towards the length of the polymer, length of the fiber or filament axis. So to get better orientation means to impart better strength, we are doing this process of drawing or stretching. So first we are doing the spinning and then drawing. And finally, we are getting the final product here wound onto the bobbin, that is nylon 6,6. So here you can see the diagram. A is indicating a hopper, means a big container where we can store or we can contain the nylon chips, which we are getting from the previous process. And then these chips are fed into a big vessel, which is known as spinning vessel. This is a spinning vessel indicated by B. And here one grid is indicated. This is electrically heated grid and which is having perforations. So this grid is indicated by C. So A is the hopper containing chips. Then from hopper, it is fed into this spinning vessel, which is indicated by B. And spinning vessel is containing this electrically heated grid. So these chips are falling on this grid, and this grid is having very high temperature, and this is electrically heated. So, and it is having perforations also. And the size of the perforation is kept in such a manner that the chips cannot pass through the perforations, but the molten mass can be passed through the perforation. The liquid molten mass can pass through these perforations. So what is happening when we are hitting these chips with the help of this grid, electrically heated grid, these chips get converted into a molten mass, and then this molten mass is passing through these perforations of the grid and collecting here in a pool form. So the pool of liquid of polymer chips of nylon 66 is collected here, and they are filtered and then filtered through this filter, and then forced through this spin rate, which is indicated by E. And spin rate is the device which we already used in viscose and acetate rayon process. It is having number of orifices, fine orifices, and it is a circular disc and having required number of orifices of required diameter to get the required diameter of the filament. So this molten mass, this liquid mass, so here we have converted this solid into liquid, that is reduction, and then this is forced through this spin rate at high pressure. So this liquid mass, this molten mass is coming out in a stream form, and this coming out is known as extrusion, reduction, then extrusion. And then here we are passing this is a cooling zone where we are passing cold air through this space. So this molten mass gets solidified and it converts into filaments. Then these filaments are passing through a steam chamber to get dimensional stability, passing through these guide rollers, and finally wound onto the bobbin. In this way, we are converting these polymer chips into filament form with the help of this melt spinning method. So because here we are converting the polymeric material into liquid form, we are reducing into liquid form by melting the polymer chips. That's why this is known as melt spinning. And in melt spinning, already you know extrusion is same, but solidification is done by passing the cool air. So by cool air, it gets solidified. In viscose rayon, we have already seen that solidification is done by coagulation bath, spin bath. In acetate rayon, it is by hot air. And here we are passing cool air to solidify the heated molten mass. And in that way, we are manufacturing this nylon 66 filament, which is wound onto this one. And then this bobbin is indicated here to show the drawing process. In drawing process, similarly as we have taken in viscose rayon manufacturing, we are using two set of rollers. Like one set of rollers is here, which is known as this pair of rollers, and one roller is indicated here. This roller is rotating at a very high speed, depending on the draw ratio required. Means कितना हमें stretch करना है, उसके according इन दोनों का speed decide होता है. And this is rotating at a higher speed as compared to this. So depending on the ratio of the speed of this and this surface speed of this roller and this roller, we are able to impart a particular draw or stretch to the filaments, and then these filaments are wound onto the bobbins. So this drawing process is basically stretching process in which we are stretching the filament which is wound onto the bobbin with the help of this pair of these rollers. This roller is at a high speed, this roller is at low speed, and the speed ratio deciding the draw ratio or amount of stretch. And then finally it is wound onto the bobbin with a slight amount of twist and can be used for further processes. So I think this is all about drawing, melting, melt spinning. And here the method is explained here. Just 2 minutes, 3 minutes, I will take more. Just whatever I explained, I am just reading out so that you can again understand the whole process of melt spinning. The chips of nylon polymer are fed through a hopper, as shown in the diagram, previous slide, into a spinning vessel on an electrically heated grid, which is perforated. And the perforations are so small that the chips do not pass through, but when melted, the liquid can pass. So the molten nylon is collected as a pool at the bottom of the vessel, and nitrogen is introduced to make an inert atmosphere. We are introducing nitrogen into the vessel. The molten polymer is capped at 288 degrees centigrade temperature and sucked by a pump into a spin rate through a filter, which I have already explained. The molten polymer solidifies as soon as it emerges out of the spin rate by passing cold air in the cooling zone. The filaments are passed through steam chamber on weight them for dimensional stability, and thereafter winding them onto a bobbin. And then drawing process. Nylon filaments as obtained are not very strong because it contains a large number of unoriented molecules, and these must be oriented so as to lie parallel to the length of the fiber or filament to develop full strength. And for this, they are drawn 4 to 7 times their original length. And this is all about the manufacturing of nylon 6,6. The remaining one more fiber we will cover from nylon, that is nylon 6, which we will cover in the next class. And also we'll take the properties of nylon 6 and nylon 6,6. Thank you very much. I hope you have taken the screenshots and your attendance also. So make the chat box. Thank you very much. So now we will end the class.